Hello, Mr. Zonker here, and this video is Triangle Congruence Part 1. Basically, we are going to be looking at triangle congruence theorems, and when we have certain information about a triangle, this might indicate that two triangles are congruent. First one we're going to look at is the angle-angle side relationship. We can see that angle A is congruent to angle D, angle C is congruent to angle F, and side CB is congruent to side FE from the congruent marks. This angle-angle side relationship can tell us that these two triangles are congruent. We also can use the angle-side-angle relationship. We can see A is congruent to D, side AC, side DF, and angle C is congruent to angle F. That's angle, side, angle, and when we have that, we know the two triangles are congruent. Let's do a few examples. Here we want to decide if each pair of triangles is congruent. If they are congruent, we want to state how we know, and we're going to be using those theorems we just talked about. For A, I can see that these two angles are congruent, these two sides are congruent, and this angle is also congruent. That would be an angle-side-angle relationship. So yes, these are congruent by angle-side-angle. Next triangle set, we've got angle over here, which matches with this angle, another angle here, which matches with this angle, and then this side here matches with this side. That would be angle, angle, side, which is one of our relationships. So these are congruent by AAS, angle, angle, side. Here we have this angle matching this angle, this side matching this side. Now, hold on a second here. This angle going to this side does not look the same as this angle going to this side. Even though we do have this angle relationship, these sides are congruent, these angles are congruent, we can see that they're not matched up correctly. This looks like angle, side, angle, where this one looks like angle, angle, side. So since those congruent marks are showing that they're not matching up in the same spots, we actually do not have enough information to say whether or not these two are congruent. So it is important to make sure that these match up perfectly to claim it's congruent by one of those relationships. In mathematics, proofs are very important. The reason why math never lets us down is because we know that it's fact. We can show it, we can prove it. It's not a basis for opinion. Today we're going to look at flowchart proofs, and this is basically a way to help us organize information and show the logic to prove something. So these flowchart proofs we're going to be doing involve these ovals or circles, and inside you're going to make a statement. On the outside of that, you're just going to give a brief reason why do we know this statement is true. Based on this statement, we can lead to another statement, and these arrows are going to show that this statement helps us logically move to the next statement. So this would be a new statement, and then we always want to provide a reason showing why we made that statement. Before moving on to a proof example, let's take a look at our proof toolbox. And these are basically some reasons that we might make statements in various proofs. So first off is given. This is any information that we are told or we can see from a picture. We know the definition of congruence. This means that angles and sides have the same measure. We can say the triangle angle sum theorem tells us that angles in a triangle add to 180. That might be useful if we're missing an angle. We also know that things are congruent to themselves. Angles and sides are always congruent to themselves, which makes sense. Then we have our two triangle congruence theorems we talked about earlier, angle, angle, side, and angle, side, angle. These both show triangle congruence if we can prove that we have these relationships between triangles. Let's use some of those tools in a flowchart example. Here we want to prove that these two triangles are congruent. So just by looking at the picture, we can see that measure of angle A is 32 degrees and measure of angle T is 32 degrees. Now we put those together and because those correspond with one another, and that's given to us. Since those are both have the same measure, we can say that angle A is congruent to angle T, and that's just the definition of congruence. Likewise, we can see measure of angle B is 75. Measure of angle P is 75 degrees, so we can say that angle B is congruent to angle P. Notice these were given, and we could say these are congruent based on the definition of congruence. The last information given to us are these side lengths. AC is 5.75, and TO is 5.75 as well. Since that information is given to us, we can say that line segment AC is congruent to line segment TO. Taking all this information together, these angles are congruent, these angles are congruent, and these sides are congruent. It looks like we have a angle-angle-side relationship. That means that these two triangles, triangle CAB is congruent to triangle OTP, make sure these points match up correctly, by angle-angle-side congruence. So we have proved these triangles are congruent. This is an organizational diagram showing how we proved it and explaining the reasons behind the statements that we made. All right, I hope this video was helpful.